Hello, this is Mr. T here. I got a request to do some volume of sphere problems from my geometry class. So we're just going to go ahead and do the circled problems. So we're going to start off with number 3, which is a cone on top of a cylinder on top of a hemisphere. And we want to find the volume of each solid and round to the nearest tenth. Alright, so the first thing we want to look at is the top cone. And we could actually just write this volume out as 1/3 pi r squared times the height plus pi r squared times the height plus 2/3 pi r cubed. Now if you don't understand what I just did, what I did was I took the volume of a cone plus the volume of a cylinder plus the volume of a hemisphere. Alright, and now I'm just going to plug in our radius, which is just 5 everywhere, and that's the height as well. Alright, so we have volume equals 1/3 pi times 5 squared times 5. Same thing over here. Alright, now I can start simplifying. So we have 25 times 5, that's going to be 125, alright, so we have volume equals 125 pi over 3 plus 125 pi plus 5 cubed is 125 times 2 is 250 pi over 3, alright. What we can do now is you can either just go ahead and plug that into the calculator since it's asking for the nearest tenth. If you wanted to, you could combine those by finding a common denominator. We don't need to do that though, so let's just plug into the calculator. So 125 pi divided by 3 is 130.9, and 125 pi, you add on to that, and then you add on 250 pi divided by 3, and we end up getting 785.4, so 785.4 centimeters cubed. Alright, once you multiply all that out in the calculator. Alright, so let's go on to number 4. Number 4 is a cylinder with a hemisphere taken out of the top. Alright, it's a cylinder with a hemisphere taken out of the top. So what we want to do is the volume of the cylinder, which is going to equal pi 4 squared times 9, and then subtract the volume of the hemisphere, which is going to be 2/3 pi 4 cubed. Alright. So let's just multiply it out. So we have 16 times 9, which is 144. So we have volume equals 144 pi minus 4 cubed is 64 times 2/3. Alright, so 64 times 2/3 is that's actually not going to simplify, so let's just do 64 times 2. So this is minus 128 pi over 3. And again, you could just do it in the calculator. And when you plug that in, you end up getting 318.3. 318.3 centimeters cubed. Alright, so that's 3 and 4. Now let's take a look at 5. A sphere has a volume of 221 and 5/6 pi centimeters cubed. What is the diameter? So we know 221 and 5/6 pi equals 4/3 pi r cubed. Alright, so the first thing I'm going to want to do is I'm going to want to turn that 221 and 5/6 into a mixed number. or not into a mixed number, I'm sorry, into an improper fraction. So when I do 6 times 221 plus 5, I get 1,331 over 6 pi equals 4/3 pi r cubed. Alright, so what I'm going to do next is I'm going to go ahead and multiply 6 on both sides. And this actually works out extremely convenient. I'll show you. Alright, so we have, I'm just going to take it over here. So 1,331 equals, the pi's are going to cancel out because you're just going to divide. Now when you do 6 times 4/3, you get 8. So we have 8r cubed equals 1,331. Now watch how this works out. We divide by 8, right? And now we're going to have to take the cube root of the whole thing. And 1,331 and 8 both happen to be perfect cubes. Alright? So when you do that, when you do take the cube root, you end up getting the radius equals 11 over 2, which the radius will equal 5.5. So therefore, the question's asking what is the diameter? Diameter equals 11 centimeters. Diameter equals 11 centimeters. Alright. And the last one we're going to look at is number 8. A hemisphere has a base area x centimeters squared and a volume of x centimeters cubed. So the x is the same. So what is the radius? So what we're actually going to do, well, the base area of a hemisphere is just a circle. So this is pi r squared. And we know they're equal. They're both x. So it's equal to the volume of the hemisphere, which is 2/3 pi r cubed. Alright, so you have that set up. You're going to go and solve for the radius. So I'm going to go down here. Pi r squared equals 2/3 pi r cubed. Alright, first thing I'm going to do, cancel out the pi's because they're going to divide. Then what I want to do is I want to move the r squared over. Alright, and set this equal to 0. So 2/3 r cubed minus r squared